Okay, now, welcome back. Now we are just getting, I should say, to an interesting part because so far what we have done, we defined data blocks, parameters block, and also we have only one block, which is essential block of our, I should say, stand blocks, which this block is called model. In the model, we have essentially two type of, I should say, inputs for that one. We can specify the priors, which is going to be our assumption about, I should say, the observations before we see them. And also that's where we define our likelihoods. Likelihoods, that's the way it designs and specifies how the data are being generated in our model then. Okay. If I'm just going to go back, I should say, to the whiteboard, which we had on a couple of, I should say, tutorials before, you saw that the thing that we did, we said that the mean, which is a parameters here, is going to be defined by this linear model. Then how about if I take this one as a likelihood and bring it, I should say, inside, I should say, the thing which I had. Then I mean that the thing which I defined here as the height, it's a normal distribution of the mean and sigma. It's going to be taken as my likelihood in the model, and I just explicitly show that onto the stand block, the model block. Okay, let's get it started. Okay, we had essentially what we said: height is a normal distribution with the central measure of the nu and the measure of the dispersion around the mean by the sigma. But when we just go to the stand, we have to put the things that I have written here on this whiteboard into some symbols and mathematical notations. We are totally fine. However, Stan doesn't understand what do we mean by the height. But if you go back to the woman, I should say, datasets, that the thing that we created, we said that we call the woman height. When we extracted the heights of these women, we just stored that into an object and we call that y. Okay? And now, if I just go back to the stand file which I have, then I can say y. You see that then instead of the y, instead of the height, we show that by the y, and we write exactly the same thing as we had. We say that the y is a distribution as normal. But as a normal, I do not just put that as an n. Instead, I just type the name of the distribution. I put that the y tilde, the normal, and what do I have inside the parentheses? You know that, as I said, if you ask from any person who knows the basic statistics and you ask them how a normal distribution is defined, they just readily answers that it's defined by two parameters, the mean and the standard deviation. And then as a result, I have to fill up inside the no parentheses with two measures, two parameters, the mean and the standard deviation. However, the mean has been defined by a model which it has its own parameters, alpha, A, and B. When we just talk about the hierarchical models and multi-level models, you see that over there, that even these parameters that we define here for the slope and the intercepts, they can be defined further down along a hierarchy to be defined by another distribution, that distribution has its own parameters, that we call them hyperparameters. We are not there at that stage yet, but I just wanted to warm up your mind that, remember, even the parameters that you have in your linear model, they can have their own distribution. And that distribution have its own parameters, that in this model, this is called hyperparameters. And that's why we call those models multi-level or hierarchical models. We are not there yet. We're just going to get there very soon, but it's good to warm up your mind. Then now, instead of just putting, I should say, the new, I just put this one here. Then I say, okay, I'm going to translate what I have written for the new, which is A times weight plus B. I know that in my model, I defined in stand A as what? As alpha. Then it's going to be called alpha multiplied to what? To the weight. But how did I define the weight? I just defined the weight, the woman weights, I stored that into an object as the x. And that's why I call that alpha. It's going to be multiplied to x. It's going to be plus. As you see, we have the intercepts in the linear model which we have, b. I define b as a parameter to what? To beta. And that's essentially, that's the translation of the model that we have, height as a normal distribution and nu and sigma, which nu is defined with a linear function, into the stand as this format. But remember, if you define in the parameter section your slope as the alpha, you have to make sure that you have the consistency to define, I should say, alpha multiplied to x. And that's why I said that take extra care and attention to do not confuse that. If your parameters alpha is defined to describe the slope, remember at the model you have to have the alpha multiplied to your variable. And the beta as an intercept, it's going to be there then. Okay. Now, we can just move on. I can say that, okay, as, oh, I was going to almost forgot. I have to close that line you stand with semicolon. And I'm just going to go ahead with the double forward slash. Just put that. It's going to be my likelihood of the model. Okay. Let me correct my spelling of the model. And also, you can continue to define, I should say, a kind of a prior at this stage. But the way that you're going to define your prior at this stage is going to be, let's keep the beta as there. It looks with the distinct space from the plus sign. It's better to just see that way. Yeah, as I was saying, at this stage, at the model, you are going to also define, I should say, your priors also, if you have any specific knowledge. But at this stage, if you do not define, I should say, the priors at the model, the stat is going to look at that as a flat priors, and it's going to be taken into account. It's a kind of a weakly informative prior then. Now, you're just going to move ahead and go ahead with the way which it is. You're not going to explicitly define the priors. We'll let the stand itself to define a flat priors for ourselves. Then we just move on to make our inference. Then we just come back to see how can we just, let's say, for example, define our priors at that stage, which is a very easy step if we just want to do that. Before we just finish this tutorial, I just want to make sure that everyone save what you have done there so far, not to lose the things which you have done. When we come back, I should say, at this stage, essentially we are done. We can come back to the R and just start, I should say, sampling and run the stand model, which is going to be essentially a topic of the next tutorials, which I'm so excited for it. And I should say I can't wait to just start the next tutorials. Then I see you at the next tutorials. And now at this stage, feel free, you can close this stand model there then. Okay, see you at the next tutorial.